Hello, my name is Joe Catalanati. I'm the product marketing manager with Dell Technologies for our entry storage PowerVault ME4. And I'm going to be talking to you in this session about ME4, but more specifically, how we apply it in our HPC, in HPC infrastructures. I think it'll be interesting. For those of you who don't know about ME4, I'm going to do a quick overview of the product, and then we'll move right into more specifics around HPC. So first of all, this is our purpose-built, optimized entry storage platform in the company for both SAN and DAS. And it's a block only. It's very simple to use, extremely fast, and has a really nice affordability model attached to it, both from a starting price as well as TCO, total cost of ownership. So from a simplicity point of view, we take a lot of pride in all of our primary storage products to really bring simplicity to bear for the IT generalist and for any other organization that may not have specialists in storage. So we make it easy to install and configure. As a matter of fact, this is a customer installable type of product. Very simple to manage through an HTML interface. It's easy to navigate. What we also apply to all of our infrastructure at Dell, whether it be networks, servers, or storage, is Cloud IQ that provides a proactive storage analytics application at no cost to you. And we're Power Edge ready, meaning our servers that are #1 in the market and PowerVault ME4 storage attach very nicely. They're validated, certified, whatever that term is, with each other. So you get the optimum experience for that DAS direct attached experience. Very fast. We have some really nice IOPS. I'll show you that in a second, bandwidth and memory and so forth. Our connectivity is both iSCSI and fiber channel, 10BASE-T and optical, plus it's SAS protocol as well. And the back-end expansion is through 12 gig SAS as well. So as you expand these arrays to get more capacity, that's the protocol. And very affordable, like I said. This is an all-inclusive play here. Just like the rest of the primary storage products that we have, they all come with all of the software that you need to really store, manage, and protect your data that resides on these arrays. Multi-protocol, scalable, all of these nice things. Cloud IQ, I mentioned, future-proof program is associated with it. If you don't know anything about future-proof, that's our customer loyalty program, and there's a lot of information about that on the web. ME4, throughout the years, has won a number of awards in the industry, all the way back to 2019. And we're very proud of that, and we want to keep that momentum going. And one of the areas that has always been a real prominent play for applying and deploying ME4 has been in the HPC market. I won't read all of this to you, but essentially the highlights here is that you can use ME4 up to 4 petabytes of capacity. That's a lot. You have 3 models available to you. Typically in the HPC market, we're looking at the 4084. That's a 5U array and 84 drives. And that's where you get your 4 petabytes from on the system. Other things here, as I've been mentioning, you have all your protocols. We run in both virtual and a linear mode. If you're running in virtual mode, that means that you are virtualized essentially as a platform and get all your data services available to you, snaps, replication, things like that. If you configure for linear mode, that's because you're probably much more interested in having the performance of the box really take over, and data services and such may be actually be implemented at the server level. So 320,000 IOPS is the max right now. The bandwidth is very powerful in both read-write sequentials. And this is a 5 nines box, meaning that over the course of the year, you're going to be down on average. I think it's like a minute and a half. It's not very long. That's what 5 nines means. And these are all dual controller architectures, so that and they're active. So if one fails, you can still keep running and keep operational while you replace the controller that has failed. So that's a really important point, where sometimes our competitors will talk about their controller architectures in an active passive manner. Well, to us, you bought the array, you bought both controllers, and we believe that they both should be running. So look at that. We also have expansion clauses for capacity expansion, but we're not here for that right now. So let's look at HPC as one of the use cases for PowerVault, because there are many that are an ideal fit for the product. But HPC in particular, as I said before, you have the 4084, the 5U84 drive system, and you can configure this in different scales. Small, medium, and large is what I have shown here, meaning that you can have scale out storage as the file system grows, as the data grows, and keep adding in that respect. And with that, you get the key here is not so much the IOPS. Yes, that's important, but it's the throughput. How fast can we get from the server to the data on the 4084, both in writes and reads? And we've got some really fast numbers here, and we're always looking at how we can improve that. As I said, when you go from the small to a large and you're starting to scale out your environment, and it really doesn't matter what you're running as a file system, BGFS, it could be Pixstore, it could be NFS, it doesn't matter. As you scale out, you're adding much more capacity. These are full RAID controllers with all of the storage intelligence. So if you need to replicate, if you need to take snapshots of your data, if you need to do volume copies or anything like that, because these are the intelligent RAID controller arrays, you have that capability. Plus you have multiple options for configuring for RAID. That's another way of protecting the data. You can do RAID 5, RAID 6, RAID 1. There's those three primarily. And again, as you move out to scale, again, those capacities really start to get huge. But they're manageable through a PowerVault manager interface. So that is an easy, simple way to navigate these boxes. And you get the direct connections, the reliability with the PowerEdge server. So when we look at this framework, and that's really all this is intended to be, is just a schematic to demonstrate the framework, where not only are we giving the file system the right performance, the right throughput, the right capacities, etc. We don't just throw it out there and say to the customer, it's all on you. Okay, we have literally an HPC and AI innovation lab that really takes a look at the infrastructure, the configurations, and the file systems that you want to test and validate. And we put them through a series of testing, whether it's new technology that's coming aboard or the existing technology that we have today, and really be able to create best practices, reference architectures, and tuning these configurations for the performance that's needed, for the efficiencies that are needed, for the scalability that's needed, and really bring to you as a customer, not just the hardware infrastructure, but how to put it all together and get the best customer experience for the workload that you have running in your business. So it's important to know that we are looking at configurations all the time. we've got papers on all of the different, or at least a handful of different HPC file systems. And 67% of the customers who do access the lab test drive systems end up buying the configurations from Dell. So it's over a third, if you will, of those customers really can see their operations at work before they spend a dime. And that really is a benefit to you as a customer. So this is a look at what the result is. So if you have a solution in mind and you want to implement it from an HPC point of view, then the solution scope is one thing in terms of what you want to have as an outcome. And the components that make it up are all very well detailed and very well explained in terms of what they do, how they do it, and how they connect. And all of that comes out of those evaluations, those test labs. And you can see here in a case of BGFS, and I'm going to use this file system here as my example throughout. So you look at, we have servers with the power edge, and those could be anything that you deem necessary. We have the storage, obviously, the networks, metadata structures or infrastructures. And so all of it is applied in the lab, connected, documented, and put out as reference architectures, best practices. It's a very detailed set of steps and processes that we go through. So if you're looking for a solution, let's just say with BGFS that relates to intensive workloads, that's something that you can define, and the lab can put that that BOM that you just saw, the BOM, together to give you something that applies to work around high IO intensive workloads with PowerVault and BGFS. And it's really an attempt to streamline what you're doing in your business so that there's not going to be months, weeks, or months on your end to have to understand, architect, all of that, and really not be up in production in a reasonable amount of time. So this whole process that we're bringing to you really helps you in time to value. Conversely, if I didn't want intensive workloads, maybe I'm just talking about large capacity workloads. Okay, so maybe with the large capacity framework or objective and outcome, maybe you want to just configure this array for linear mode, as I talked to before, because now you're just looking at capacity. All right, and you want the best performance. You don't want all the data services. And so maybe that's something that you might want to consider. But again, the outcome, capacity workloads or large capacity workloads, intensive workloads, whatever it may be, the outcome, we will build it, and we call it a building block of both servers and storage and connectivity all together so that you have the best experience when you get it and put it together. Some customer testimonials that we have that you're certainly welcome to take a look at. Durham University, where they used ME4, the 4084, the large box that you see over here on the right, and they used it in combination with Lustre, and they did it in terms of all their research that they're doing around cosmological research that they're doing. I can't say the word. And they're really happy with it. And they have some great testimonials online that you can take a look at. Another HPC file system, PickStore. Again, we brought that to bear with PowerStore in play, giving them all around simplicity, which was a requirement. They definitely wanted the best performance, the best capacity, and they got what they needed, and with a lot of headroom to grow into, up to a petabyte. And they did that in 5U. That's what this box is here on the right. It's a 5U 84 drive. And because it's a full RAID controller with all the intelligence, they get all of the data management stuff right with it. So they were very happy with it too. That's the presentation, because I know we didn't have a lot of time, I think 15, 20 minutes or something like that. But I have two gentlemen, Robert and Keith, that are manning the Q&A. Hopefully you have some, and I just want to thank you all for attending and look forward to doing business with you in the future around our entry storage PowerVault, and trying to do our best to achieve the outcomes that you want with HPC. Thank you.
Thank you, Joe. And if we have any questions, feel free to ask them now. This session was recorded, so it will be posted on our microsite if you would like to review it at any point. I also have sent out a spin and win in the chat if anybody wants to take a shot at winning a prize from Dell, and we will get right into the questions and answers.
I have a question. I have heard that on PowerVault, there's not only just the ME 4024 and 4084, but there are also like JBODs and expansion chassis. So
Yes.
Can you tell me more about that? Like, in other words, if I just want to, frankly, add on storage capacity, is there an easy way to do that?
There is, and it's a good question. Let me go back to the slide that I think had some of those in here. Here we go. We have the main arrays. These are what we call RBODs, RAID controller boxes. And again, this is where your controllers are, all your intelligence, all your software, everything that runs that's needed, the firmware, etc. on the 40, 12, 24, and 84. Those numbers relate to number of drives, okay? The first two are 2U. If you want to add a capacity to any one of them, frankly, you have the option to use the ones on the right, the 412. So we just yanked the 0 out. So you have a 412, a 424, and a 484. Again, 12, 24, and 84 drives. Those can attach to any of the other three on the left. Now, there are some rules, and they're listed here. So if I'm running as a primary storage array, the 4012 or the 4024, the most number of expansion units that I can attach to either one of them is 9, okay? And they have to be either the 412 or the 424, okay? I can mix them, or I can do all 9 as a 412, all 9 as a 424, or I can do 5 and 4, 4 and 5, whatever it may be. With the 5U over here, the 4084, what I can do is expand that only with a 484. And those, the maximum number of expansions are 3. That's what gets you the 4 petabytes and or the 336 drives, whatever comes first. Okay. Can I expand the high capacity dense unit with the 2U units? Yes, I can. When I put a 484 underneath or expanded on a 4012 or a 4024, I can only go up to 3. Okay, so there are some configuration rules, but essentially to the question about expansion, we call it EBODs, you can call them JBODs, whatever. We also have another family of products that are MD class, MD 1400 and 1420, that are also very nice JBODs only. So they're available as well. Hopefully that answers your question.
And also, I want to call out one thing also from an expansion standpoint. On the ME 4012 and the 4024, when you configure those, you have the ability to choose either a single or dual processor. On the ME4084, it has to be dual. But if you choose a single processor on one of the 2Us, you cannot add any expansion units behind it until you populate that second controller.
Yeah.
And
Which
then
is-
also, I'm sorry, go ahead.
No, finish.
Oh, no, and I just wanted to touch on one thing, and Joe kind of did, but so Jen, I believe when you mentioned JBOD, I want to call out that the ME412 and the 424, they cannot be directly connected to a server like a standard JBOD. They require one of these RBODs to be plugged into. If they need if a customer needs like a 2U JBOD, they would use what Joe references, the MD1400 or 1420. Now, the ME484, it can actually, and this kind of gets confusing, it can be used as a JBOD because we didn't have a dense JBOD. So you can either plug that into one of the RBODs, or you can plug it directly into a server.
Yeah, it gets a little cumbersome and confusing. That's why the lab is there to help sort all that out. If you, another point here is virtual linear modes. You have to declare, I think default is virtual when you get a chip, but if you wanted to do linear mode, you have to declare that up front when you buy it. And once you do that, you can't switch. Okay, you just can't. So, that's another thing that would be a determination in the lab testing and validations and configs and all of that. So, that's why I use the examples of, am I looking at, where is it? Intensive workloads? Am I looking at large capacity? Different types of configurations, different types of outcomes that I want will help determine where that configuration is, all the componentry, how the array needs to be configured, what type of protocol is best. So it's really important that when we put all this together for you, you don't have to think about all the stuff that I just said and everybody else was saying about, this connects to that connects to that can't connect to that. So I wouldn't worry about that. I would just look at it from a standpoint of, you have a trusted partner in Dell Technologies relative to HPC, and we can handle a lot of your different outcomes that you need to achieve before, like I said, before it even gets implemented.
Thank you.
You're welcome.
Right, well, if that's all we have for questions, then I will end this recording. Thank you again, Joe. Thank you, Keith and Robert, for helping with the Q&A. And everybody have a great day.
Thank you.
Thank you.
Take care, everyone.